Next is a rather famous experiment by Faraday itself. Is basically when he uses a DC power supply itself. When he actually closed the switch, what he actually noticed is that there is actually a slight deflection. And key thing, there's a deflection, and then what happened? It goes back after a while. Which means basically, when I close a switch, right, you can just imagine is I have no magnetic field line, suddenly I have magnetic field line, and during that short period when you suddenly change from 0 to half, then there will be a deflection because that was a change. But once you stabilize at that magnetic field itself, basically there's no more changes. Remember, you have induced EMF if and only if you have changing magnetic field lines, which means if my magnetic field line stabilizes, there is no more induced current. Okay, and then what happens is if I open the switch, you will actually notice the deflection, and this deflection more specifically is in the opposite direction. Okay, so because it's actually in the opposite direction, because when it's basically now I from half to 0, which is opposite of from 0 to half. So basically that is why normally if you want to use this setup itself, we must use AC to show that it's to have induced EMF, constant induced EMF, or basically to always have induced EMF. If you use DC, you have to keep opening and closing the switch itself. So if you notice, if I were to have current flowing through, it will be in this direction, right? Which means if I use my right hand grip rule itself, this is north, this is south. So basically when you close the switch, it's as if I introduce a north here. So what happens is there will be by Lenz's law, there will be a induced current in this direction itself. So you can see the induced current will be in this direction, which will be like this. So at the very start, you actually deflect to the left, and then afterwards, when you close the switch, you actually deflect to the right itself.